This week we will be discussing composite functions, and composite functions appear in your Math 1314 section 1.7. And so whenever you see this symbol, you take the composition, the functions. And so this right here is read as f of g of x, and you can write it as f of g of x. And basically what happens is the function furthest to the right is going to go inside all the time. So if you had g composed of f, then the function f would be inside. So the function furthest to the right is the one that goes inside. And basically what it does is that it takes the output of g of x and it makes it the input of f of x. So first you evaluate g of x. Whatever you get, then you plug in for the function f. So let's look at an example. So we have f of x is equal to 2x, and g of x is equal to x plus 7. And so I always encourage people to rewrite this statement as f of g of x, because it makes it a little bit more clear on what is going to have to happen. So we have f. G of x is given right here, so we're going to plug that in. So g of x is equal to x plus 7. So that's going to go in our parentheses. And now we want to evaluate x plus 7 for the function f. So whatever is in the parentheses, we're going to bring and substitute it in for our x in the function f. So here we have a 2, and then x is going to be x plus 7. Then we want to simplify, so we get 2x plus 14. So the composition is equal to 2x plus 14. Let's try the next one. G composed of f of x, we can rewrite as g of f of x. So first, we want to evaluate f of x. So in this case, f of x, they tell me is 2x. Then whatever's in the parentheses, we're going to evaluate for the function g. So we're going to substitute it in for the x in the function g. So here we would get x, but we're going to replace that with 2x plus 7. And then this would be our answer. Let's try letter C. So I have f composed of g of 2. I can rewrite it as f of g of 2. And so first, we're going to evaluate what g of 2 is. So for g of 2, my function is x plus 7. So the 2, we're going to replace it in for the x. So we would get f of 2 plus 7, which is equal to f of 9. And so now we can take our number in the parentheses and plug it in for the function f of x. So here we would get 2, and then in place of the x, we're going to replace it with the 9. So we get 18. So the composition f composed of g of 2 is equal to 18. And notice here, if you had put the 2 in for the x over here, we would have had 2 times 2 is 4 plus 14 is going to be 18. And so for this one, you can plug in the 2 in for this x because we already figured out what g of f of x is. But I'm going to go ahead and just work it out so we can see how it works out. So here we would have g composed of f of 2. So for f of 2, we're going to replace the x with the number 2. And remember that the functions are f of x equals 2x and g of x is equal to x plus 7. So in the place of this x, I replace it with 2. 2 times 2 is 4. And now we're going to evaluate 4, so I'm going to plug it in for my x here. So I get 4 plus 7 is equal to 11. So g of f of 2 is equal to 11. Okay, let's try a couple more. So first step is to rewrite this as f of g of x. Okay, so g of x here is 2x squared minus x minus 1. And so we're going to take everything in the function, everything in the parentheses, and we're going to plug it in for the x. So we're going to have 5 times 2x squared minus x minus 1 plus 6. Then we can simplify. 5 times 2 is 10x squared. 5 times negative x is negative 5x. And 5 times negative 1 is negative 5 plus 6. So this would give me 10x squared minus 5x plus 1. Let's look at letter B. So g composed of f of x is the same as g composed of f of x. So here I'm going to replace my f of x with 5x plus 6. And then everything that is in the parentheses, I'm going to replace it for my x in my function g. So I would get 2 times 5x plus 6 squared minus 5x plus 6 minus 1. So here we get 5x plus 6 times 5x plus 6 minus 5x minus 6 minus 1. So I distributed the negative in here. So we're going to end up with 5x times 5x is 25x squared. 5x times 6 is 30x. 6 times 5x is 30x. 6 times 6 is 36. Minus 5x minus 6 minus 1. Gather our like terms. So let's multiply the 2 in here. 2 times 25 is 50. 2 times 25 is 50x squared. 2 times 30 is 60x. 2 times 30 is 60x. And 2 times 36 is 72. And then we have minus 5x minus 6 minus 1. So last, we need to gather our like terms. And I'm going to go ahead and write it right here. So this is going to be 50x squared. 60x plus 60x is 120x minus 5x is 115x. And then we have 72 minus 6 minus 1 going to be 65. So my answer for g composed of f of x is equal to this right here. Okay, letter C. We have f composed of g of negative 1 is the same as f of g of negative 1. So if we plug in negative 1 for all the x's in the function g, then we get 2 times negative 1 squared minus negative 1 minus 1. Negative 1 squared is 1 times 2 is 2. Negative negative is positive 1 minus 1. 2 plus 1 is 3 minus 1 is 2. Then we're going to plug in the 2 for all the x's in the function f. So we get 5 times 2 is equal to 10 plus 6 is 16. So f composed of g of negative 1 is 16. Okay, let's try example 3. So we would have f composed of g of x is equal to f. G of x is x squared minus 3. And now I'm going to substitute x squared minus 3 for all my x's in the function f, which is x squared plus 1. So we get x squared minus 3 squared plus 1. So if we multiply it out, we get x squared times x squared is x to the 4th. X squared minus times 3 is negative 3x squared. Negative 3 times x squared is negative 3x squared. Plus 3 times 3 is 9. So we have x to the fourth minus 6x squared plus 10. And then g composed of f of x. Wherever I see an f of x, I'm going to substitute, let me write it here. F of x is going to be x squared plus 1. So now I'm going to take the x squared plus 1 and plug it in for all my x's in the function g. So we get x squared plus 1 squared minus 3. So we have x squared plus 1 times x squared plus 1 minus 3. Multiply it out, we get x to the fourth. X squared times 1 is x squared. 1 times x squared is x squared. 1 times 1 is 1. So we end up with x squared, x to the fourth plus 2x squared minus 2. Okay, the next one, f composed of g of 2. We have f of g of 2. So here we end up with f of g of 2. So we're going to substitute the 2 in the x for the g function. So we get 2 squared minus 3. 2 squared is 4 minus 3 is 1. And then we're going to plug in the 1 for the function f. So we end up with 1 squared plus 1, which is going to be 2. Okay, the next one is g composed of f of 2. I can rewrite it as g of f of 2. So wherever I see an x in the function f, I'm going to plug in a 2. So I end up with 2 squared plus 1, which is going to be 5. And then we're going to substitute the 5 into the x's of the g function. So we get 5 squared minus 3, which is 25 minus 3, which is 22. The last part is finding the domain of a composition function. And there's two things that we have to consider. The first one is whether x is in the domain of the function g. And the only reason we put g here is because you have the g as your second function. If you were to have g composed of f, then we would be looking at whether x is in the domain of f. Okay, so this will alternate depending on that second function that you have here. So once you check that, then number two is to find the domain of your composition. Okay, so let me break that up into pieces here. So given f of x equals 4 divided by x plus 2 and g of x equals 1 divided by x, find f composed of g of x. So we can write this as f of g of x. And I'm going to write g of x, which is 1 over x. And then anywhere I see an x, I'm going to replace it with 1 over x in the function f. So I'm going to have 4. And then I have 1 over x plus 2. And then we want to simplify. So one of the easier ways to simplify this is to multiply everything by the denominator in that fraction. And so here we would end up with 4x. The x's would become a 1. So we just get 1 plus 2 times x is 2x. So this is your composition. So that says find the domain of f composed with g. So the first thing is to look at the second function. In other words, this inside function. So g of x is equal to 1 over x. And figure out what the domain is for that function by itself. Okay, so here we know that we cannot have 0 in the denominator. So x equals 0 is excluded. So my domain here is going to be negative infinity to 0, union 0 to infinity. Okay, and then step 2 is to actually look at your result for the composition itself. So we have 4x over 1 plus 2x. So we're going to set the denominator 1 plus 2x equal to 0. So if I subtract by 1, I get 2x equals negative 1. Divide by 2. So x is equal to negative I half, which means that this value is excluded from the domain. Okay, so the way we could write this is the domain goes from negative infinity to negative I half, union negative I half to infinity. So after you have the two pieces, then you want to ask yourself, what does this have in common with this? And one of the ways that you can figure that out is if you draw a number line, you have 0 in the middle, 1, 2, -1, -2. And so for the first part, for g of x, it says that the domain is all these negative numbers all the way to 0, and then all these numbers over here. Oops. Okay, and then for the second part, this is negative I half. For the second part, your domain is all these numbers over here, all the way to a half, and then it continues all the way over here. Okay, so your domain is basically where you have both types of shading. Okay, so if you notice at this value, you don't have both types of shading, you just have the red. And then at this value, you don't have both types of shading. So your domain is going to be all real numbers except 0 and negative a half. Okay, so how are we going to write that? We can write it as from negative infinity to negative a half, union negative a half all the way to 0, union 0 to infinity. So for this week, we were focused on composite functions.